model, the anti-aging model for assessment of application software. So here is my outline. I will start my presentation with introduction, followed by background study and related work, the empirical study, the purpose model for anti-aging, the anti-aging, and also the conclusion. Software aging is defined by the degradation of software performance throughout the execution. Software aging can be detected in application software when the long-running software shows gradual degradation and deficiency in terms of performance and quality. Software aging is a progressive process that may lead to the degradation in quality of service, frequent failure, accumulation that may result in declining system performance, and even system crash. As increasing the level of software aging, the performance of the software will degrade. When the quality of service is lower than a specified threshold, the system cannot provide satisfied performance anymore. So there are two types of software aging that have been identified by partners. First, caused by the result of the changes that have been made. And second, the failure of the software or system to adapt with the dynamic environment. Here is software aging issues. Aging is an inevitable process that every creature will go through. This phenomenon is applicable to the software environment as well. So, the past researcher stated that it will give a negative impact to the application and operation system, organization, and user economics. Effects on the operating system at resource levels such as non-release memory, run-off of data file fragmentation, and also debug error. So these features have been evolved to the mobile application software, where they are studying the aging to the Android OS, cloud computing, and so on. So there's a tragedy that happened according to software aging, which is RN5 and pattern install defense, which is killed 28 people and 100 injured. This session discussed on the empirical study that had been conducted in Malaysia. The objective of this empirical study is to examine the awareness and acceptance of the software aging phenomenon among software practitioners in Malaysia. And second, to examine the classify the aging factor that influence the aging of application software. The empirical study was carried out in various sectors and agencies, both in private and public sector. So, table shows the background of the respondent that come from diverse types of organizations and backgrounds. This study also determined other possible factors that might influence and contribute to the software aging for application software. There are the 20 metrics have been identified from the literature review and brainstorming among our research team, which is led by software engineering experts and academicians in Malaysia. So from the finding, the software aging factor have been mapped and classified into 3 categories, which is human, environment, and functional. The development of software aging model is motivated from the finding that we obtained from previous empirical study. So there are 4 components of the model, which are aging factor, instrument, assessment process, and report. So for instrument, there are 2 objectives, which are to measure the aging level of targeted software, and it can be used by organization or company, the stakeholder, the owner of the application software who want to investigate the status of the software. The assessment process aims to do the following tasks, which is measure the score for each aging factors, measure score for the overall factors, mapping the level of the software aging. So after that, the last component of the model is report. Report on the aging status is generated after the completion of the assessment. The report consists of software aging index level, which are defined as young, semi-old, and very old. If the assessment shows the aging score is very old, the anti-aging action will be suggested and included in the report. We have conducted a case study to validate the model. We ran the case study in one of the semi-government agency in East Coast Malaysia. So the aims of this study was to assess the 3 application system that operated in the organization. Assessment result for case study number 1. The average cumulative for GSX system is 47%, which is met into aging index semi-old. And the second one, for the SX system, the score obtained is 66.9%, which is mapped into aging index level of semi-old. And the last case study to the ESX system, it obtained 76.8%, which is equivalent to young in aging index level. Okay. The anti-aging action are proposed to be applied on the software that has the lowest score during the assessment that has been described in previous section. Previous researcher revealed that one way to handle software aging was through systematic maintenance of the software. So the anti-aging action are derived from software maintenance activity. So here are anti-aging factor for functionality factor. We have 6 metrics which can be evaluated: time responsiveness, user requirement and expectation, functionality, degradation of performance, software reliability, software faults and failures. And second one is anti-aging for environment factor. We have 6 metrics also: dynamic to environment change. The suggestion of anti-aging is by corrective maintenance, easy maintenance for environment change, and easy maintenance for business change. The last one, anti-aging for human factor, such as upgrading and maintenance expert, software quality practice, software management capability, and user interface. So the anti-aging action can be used or can be applied in order to counteract with the problem if there is a problem in user interface, for example. So we can apply the adaptive maintenance, such as improve and enhance the software for user-friendly business and usability aspect. Improve and enhance software functionality. The proposed anti-aging action is suggested to the system that have been tested in case study, in the previous case study, which I discussed in a previous slide. So we choose the application that obtained the lowest score among 3 applications that has been tested, which is GSX system with the percentage of 47 and falls under semi-old level. So we identify the lowest score among the metrics, which is time responsiveness, user interface, cost and software maintenance, and software upgrading. So for the conclusion, this paper has presented background work on software aging and discussed the aging effects from various aspects and dimensions. The finding of empirical study conducted by our research group were used as initial work to development of the model. This study extends further by summarizing the software maintenance activity as anti-aging guideline and action in order to counteract with the aging phenomenon. The guideline can assist the organization or stakeholder to decide the action that has to be taken to overcome the software aging. That's all. Thank you.
So this one I've actually written a paper on somewhere back. So maybe I have some relevant thoughts. It's an interesting approach to have the metrics and things to make the assessment qualitative. quantitative and not just qualitative. I think in my paper, I was advocating that aging is a problem for software. But unlike hardware, which ages through use and mechanical failures and things like that, software has these other factors. So I'm interested in the work that you've done. My question is, have you actually applied these in some measurement that you can publish? I didn't see the data that would lead me to believe that these are practical measures.
I have already do a case study and applied it in these 3 systems that have been conducted in one semi-government agency.
So, and I saw those, but it wasn't clear to me how big the data sets were. Can you understand? Are these small systems, college systems, student systems, or are these systems actually out in industry? And if they are, how large are they?
Because at this point, I choose the system that have developed by their agency. So they need to know the status of the software. So what to do if their software face the aging phenomenon. So normally a GSX system is just like a GIS system. It stores data that shows the geographical information about that area. So it's quite a big software. So that it has some problem like running time responsiveness because of that.
A couple of things come to mind for me. Part of it's similar to what John was just saying, but the different types of software, you kind of identified some of them when you issued the survey to sets of different categories. The software in some of those categories are very different. Like web software is very different than command and control software. And so the aging in those 2 environments would be different. And I would contend anybody that's doing DevOps and Agile well with refactoring, aging is going to be a lot different than in a command control system that's only delivered updated 1 time a year. And so how do you know the difference there? Those are the questions I would have, is that you have to kind of focus in on the same kind of software and then do that by category of software to understand the difference. Because like I said, in one area, I'm not even sure aging is a problem. That's my contention. I can't back that up. I'm just listening to your point. So that's some observations.
Because for my study, I focus only on application software. But software aging research have many categories. So you can do a study to the operating system.
Okay. So you're focused on application software, not web-based software, or kind of independent of development methodology as well?
Yeah, independent methodologies.
So it could have been a waterfall development model or an agile development piece of software or whatever.
Yeah. Thank you.
I have no further questions. That is actually my project. Zuraini is my PhD student. But this paper is based on a master project. So currently we are extending this anti-aging research towards predictions. How are we going to predict aging on a certain somewhere that working in a certain environment?
We are at the stage of identify the parameters that can be used as a prediction to the application aging.
Thank you for the comment.